Hello everyone, we are Cool Care and this is Sprint 3 presentation. Project we chose was to improve the healthcare and reduce cost for members with the complex needs. Members with complex needs are amongst the top 1 to 5% of people who account for 50 to 70% of healthcare spending. In fact, less than 1% members account for 30% of healthcare cost. A question we may ask: could a software application solve our problem? With some additional research, we came to two main focus points. First, focus on high cost complex needs population, which is about 1%. And the second one is look at the other different options or delivery of care. Let's focus on the high cost complex need population. But what we should do. First, reduce costs through reducing administrative rework and improving health outcomes. Second, deliver a superior experience to accelerate the impact in the market, nurtures brand, loyalty, trust, and mitigates reputational harm. Third, enable growth and retention through non traditional product opportunities and shared values. Fourth, identify high cost members and reduce utilization rates on more expensive healthcare services such as ER visits, urgent care visits, through early detection and patient engagement. Let's look at what are the other delivery of healthcare. Evaluate and analyze different programs such as care management and patient centered medical home to identify cost reduction opportunities. For example, care management can reduce hospital at readmissions, and that would save us a lot of money. A patient cared medical home may reduce cost by reducing inpatient admissions and ER visits. Below are just the references of the above research findings. Goal of this project is to provide leaders with actionable insights to help patients who need the healthcare the most. So we created this wireframe using a software called raw.io, and this is the prototype of how the final dashboard will look like. This is subject to change. On the left hand side, a user will have ability to select what local market they are interested in looking at. On the right hand side, it shows the total spending that for a particular year or month. If you go further down, you will see how many patients are using what services. For example, let's say 13,000 patients are using urgent care, but about 2,000 patients are using ER. Same details will be provided with facility, non-facility, and how many patients are taking medicine. It also presents with the total amount spent on for each department. If we go further down, it will show how many patients are enrolled in a clinical program, which is to help them. And the bar graph on the right hand side of that little box shows that the females are higher in this particular program. And leaders should make decision or ask questions on why males are less or why other genders are less. In the center, we see that patients are not enrolled in clinical program, and we see that female more count of female are not enrolled in clinical program, and we should do something more about it. At the very bottom, it shows how many patients need care, and with some visualization on how many of those patients are male, female, or other gender. Presented is mentored provided wireframe, and essentially they are also trying to glean actionable insights from the healthcare data. Over to you, Niraj.
Thank you, Dhruv. We choose cloud-based architecture to support scalability and easy integration. S3 storage is used to store static resources like uploaded data files and front-end resources. The uploaded data files should be imported to application database using AWS Glue ETL service. AWS RDS service will be used to host the application database, which is going to be Postgres. AWS Lambda will host our business logic to extract data from database, aggregate it, and serve it to app and API endpoints. AWS API gateways are used to serve RESTful endpoints. Prominently, we'll be using React.js for front-end, Python for ETL and backend business logic, SQL on PostgreSDB for database queries. Here is the architectural diagram. We are using model view controller approach. Data is uploaded to S3 bucket. Then it gets imported to Postgres database using AWS Glue ETL. AWS Lambda should detect upload to database, run computations, and send updates to the dashboard on front end and to the RESTful API calls. We choose AWS because it comes with bunch of pre-built services. S3 to host web application because it has 99.99% data durability, built-in scalability, inherited data security. It also simplifies data monitoring and management. S3 enables definition of access points, which boosts Amazon product interoperability. Also, it's extremely scalable. Other Amazon services like Glue ETL for data extraction, Lambda for data computation provides easy development without worrying about DevOps complexities. We have pretty basic deployment pipeline at the moment. Commit changes to GitHub, test and get them approved for acceptance and release to production. Biggest concern of this project is data security and control. Although the identity details of all records are masked or edited by data provider, it is still sensitive data. The application is storing this data on cloud, which is risky. Endpoints exposed to end users should be secure and protected from external attacks. To handle this, as stated before, S3 has inherited data security and integrity from AWS. Still, we should follow AWS security best practices to avoid any data breaches. To secure endpoints from attackers, we should follow industry standards for web security. Second challenge would be learning AWS. Not everyone in team is familiar with AWS technologies. It is known to have steep learning curve. Although not everyone, some of us still have a good grip over understanding of this technology. Rest of the team will be working closely with these resources. Rather than focusing on learning everything in AWS, our focus will be learning bare necessary technologies required for this project. We are in third sprint of our project and have finished with initial design as well as required techs for the project. Next one sprint will be spent in development and following in testing. After an acceptance test, subsequent improvements to the app will be deployed and tested over following sprints. This concludes the initial design sprint, that is sprint 3 of Cool Care team. Thank you.